Here is Chapter 11.4. We are going to translate and shift around sine and cosine functions. Remember in our last video we just discussed sine and cosine functions in general. I'm going to really briefly just graph a sine function again to sort of refresh our memory. The sine function is measuring how high up the y-axis a point is as an angle theta in standard form increases. As the angle increases, the y value gets higher and higher and higher. It eventually plateaus at 1, and then it starts coming back down again, and it'll go down all the way until -1. This is happening as this angle theta grows and grows and grows and grows and grows. So to make graphing simple, we plug in numbers for theta that are easy to find their sine values. So I'm going to graph theta and f of theta. If I plug in 0 for my angle, the y value is 0. If I plug in 90 for my angle, the y value is 1. That happens right here. 180 has a y value of 0. 270 has -1. And 360 gets us back to 1. So it graphs like this. Middle, high, middle, low, middle, high, middle, low, middle. I'm going to call this 1 and call this -1 just to make the graph a little bit bigger and prettier. Okay, that's sine. I want to stress, like I did last video, that this shows 5 points, but only 4 steps. Because we start and end at this point, it takes 1, 2, 3, 4 steps to cover 5 points. So the reason that we would find our scale was if we took the period and divided it by 4, that would give us our scale. We divide it by 4 because it takes 4 steps to get around the circle. Okay, all we're going to do differently today is throw in h and k values to slide the graph around. This is the general form of a function, sine or cosine. There's b values that change the period. There's a values that change the amplitude. These h values are called a phase shift. They move everything left and right. And these k values just translate up and down. A, h, and k are things you have seen in this class many, many, many times. B is new. B does a horizontal shrink or stretch as opposed to a vertical one. So like remember quadratics, here's your basic quadratic, y equals x squared. If we double the value in front of, if we double the a value, sheesh. If we double the a value, sheesh. If we double the a value, all the y values get twice as high. But what we could also think of that as, instead of all the y values getting twice as high, we could think of this as all the x values get scrunched in twice as far. It's like this x value got pulled in tight, and this x value got pulled in tight. So that's a horizontal scrunching as opposed to a vertical stretching. Well, with trig functions, it's actually really easy to see how those are separate operations, at least at first. They can become the same operation later. So I'm going to graph this function right here. The a value is 2, the b value is 1, the h value is -90. Because of that minus there, the h value is actually -90, and the k value is -3. Typically, we would graph these by making our x and y axis in the middle, and then starting middle, high, middle, low, middle, high, middle, low. This is cosine, so it starts high. Cosine starts high. So one way we could do this is we could first just graph the parent function. We could just graph y equals cosine x. Okay, y equals cosine x graphs like this. High, middle, low, high, middle, low. And I should put some labels on this. This would be 180. This would be 360. This is 540. So I'm counting by 90s technically. Then what we could do, and some of you are going to really like this method, like this will be how you prefer to do it, is take every single one of those points and translate them left 90 and down 3. So left 90 means this point moves left 1 box. That's 90 units, but 1 box, because I'm counted by 90s. So here is left 90 and then down 1, 2, 3. So that point is now here. This point goes left 90 and down 1, 2, 3. So that point is now here. This point goes left 90 and down 1, 2, 3. So that point is here. And then the graph would start to do this. Then I'd have to deal with this amplitude. I'm going to talk about that in a second, but I want to give a moment for this idea of translation to sort of sink in. What I just did was took this blue graph and moved the whole entire thing. I'll just grab it. Take that blue graph, take the whole entire graph, and move it left 90, down 3. Let me see if I can get a nice clean curve I can do that with. Just going to trace this one, try to grab it, and move it left 90, 1, 2, 3, down 3. You get that graph. That's all this is doing right here. This is just a translation, left 90, down 3. I still have to deal with the amplitude, however. The amplitude is now 2. So I would need to take all of that yellow stuff, basically, and double it. Make it so that the y values go twice as high and twice as low. And now the amplitude is 2. And I think that's an okay way to graph. I really don't hyper recommend it. I think it's a lot of steps for something that could be done a lot easier. So let me show you the easier way I think this could be done. If you feel like you're at the point where you can graph sine and cosine pretty well, or at least well enough, that means all you really have to do is go middle, high, middle, low, middle, high, middle, low. I'm going to grab everything and move it up 1. There. Yeah. And what I'm going to do is draw a new x and y axis. And it's not really an x and y axis. It's a new horizontal axis that my new graph is going to be based around. So since everything was translated left 90 and down 3, I'm going to draw a line that's left 90 and down 3. So here's a line left 90. Here's a line down 3. I'm going to graph everything based off of that blue line that I just drew. It's like that's my new xy axis. It's not, but that's where everything's going to be centered around. Cosine, sine starts middle would be here. Cosine starts high, so it's going to be here, because it's up 2. The amplitude is 2, so I start up 2 units from the middle. High, middle, low, middle, high, middle, low. High, middle, low, middle, high, middle. This is y equals 2 cosine x plus 90 minus 3. That's how I do all my cosine graphing. I find the new center, and I give new axes about which to send the graph, both the horizontal and vertical axis, that's centered on wherever hk is. -2 times the sine of 3x plus 4 in radians. This was not translated left or right at all. If you translate something left to right, that's called a phase shift. Okay, the h value is your phase shift. It moves things left to right. We don't have an h value. Our h value is 0. I have a is -2, I have that b is 3, and I have that k is 4, but no h value. So the period of this function, I'm graphing it in radians, so it's 2 pi over b, which is 2 pi over 3. We had one of those last video, actually. The scale is always going to be the period divided by 4, which is 2 pi over 12, which is pi over 6. So I'm going to be counting by pi over 6s. Now everything on this graph is moved up 4, which is really quite a lot. So I'm going to put my y-axis down pretty far. I'm going to put it all the way down here, actually. There's my x-axis. I'm going to put my x-axis all the way down here. That actually kind of makes the writing nicer. If I'm counting by pi over 6s, here's 1 pi over 6 and 2 pi over 6s. So every other box is a pi over 3. Right? If I'm counting by pi over 6s, then 2 boxes is 2 pi over 6s, which is a pi over 3. So I'm counting by every other box is pi over 3. Now this hasn't been moved left or right at all, but it has been moved up 4. So this is going to be the new center of this graph, the midline of this graph. Now I've done the hard work of setting up a scale and finding the center point of this graph. With the center point found, everything else is simple. Sine starts middle. The a value is negative, so I'm going to start by going down 2 and over 1. Middle, low, middle, high, middle, low, middle. I follow my pattern, middle, high, middle, low, middle, high, middle, low. Oops, did the left side wrong. To do the other side, it's going to go from middle to high, because it's going to be, the graph's doing this. Low, middle, high, middle. There's the function. It's beautiful. Again, the key is finding your scale. You find your scale, and you find your center, and you try to make sure your graph hits the center, and mine kind of missed. But you find the scale and the center, figure out if you're starting high or low, things just happen. It takes some practice, but it gets familiar. Okay, here's our last problem, and kind of our first application type problem for this trig stuff we've been doing. A Ferris wheel, which is a nice old-fashioned ride at a carnival, has a radius of 30 feet. So this length here is 30 feet. The center of the wheel is 38 feet above the ground. So we are going to pretend like it's just sitting on a big pillar, and that this height right here is 38 feet. Write and graph a function that gives the height of a car, like, something on the Ferris wheel. There's probably a few of these cars on the Ferris wheel. The height of a car given the angle and standard position as input. So that might be tough to understand at just reading it, but we're going to make a function that is f of theta equals something, where we plug in an angle and we get out a height. But to get the height, we're going to have to do like a calculation of some sort, and odds are pretty good that calculation will involve sine or cosine. So I'm going to kind of clean this up a little bit. We basically have a unit circle, only this point here isn't 0, 0. This point here is 30, 38. Because this is the point 0, 38. Because the center is starting 38 feet above the ground. If our angle in standard position is 0 degrees, and that would be this is a 0 degree angle. If our angle is 0 degrees, our height, and height is the y value, height is the sine value, our height is 38. So I'll kind of try to explain that again. If the rotation of this wheel has gone 0 degrees, starting from this point here, if we've gone 0 degrees, the height that we're at is 38. Then let's say it rotates 90 degrees. We pick 90 because it's easy. If it rotates 90 degrees, how high is the car? Well, if the radius is 30, and it started at 38, it's now at 68. If it goes another 90 degrees, if it's gone 180 degrees, we're back at 38. And then yet another 90 degrees, putting us at 270 total. It's down to just 8. Because this cart right here is 8 feet off the ground. Finally, finish up a 360. We're back at 38. I can start by graphing that function. I think it'll probably be easiest done with a pretty wonky scale. So here's what I'm going to do. Finding the best way to fit the numbers like 8, 38, 68, etc. is going to be kind of a pain unless I just sort of break this up and do it as I want. So I'm going to call this right here 38. And this will be 68, and this will be 8. So this right here is like my center line. At 0, so I'm counting by 90s, and that's nice. At 0, we were at 38. At 90, 68, and then 38, and then 8. I'm just going to keep going around and around and around, like so. Let me start by just graphing one cycle, though. There's one cycle of this graph. Because this is asking for the height, this is a sine graph. Because the graph is starting in the middle, it's a sine graph. I'll finish it up real quick. High, middle, low, middle, high, middle, low. This function is going to be written as a sine of theta. The amplitude of this function is 30. It goes up as high as 30 from the middle, so our a value is 30. This function wasn't translated left or right at all, but it was translated up 38. So that's the function that gives the height based on the angle. 30 sine theta plus 38. But plugging in the key simple right angle points and then thinking through their heights is the key to this problem. You have a focus problem just like this. I don't want to say that. Cut that out, Grant. Okay, a horizontal translation of a sinusoidal function is called a phase shift. That is the h value. A cosine function can be phased into a sine function. Didn't really talk about this, but if I have sine theta, I could take cosine theta and move it left 90. It becomes sine theta. I'll just do that real quick. Here's sine, middle, high, middle, low, middle, high, middle, low. If I take a cosine function, but I start at left 90, right 90. Yeah. I don't know if I talked about that enough, so let me just show that real quick. Sine theta is going to be the same as cosine of theta minus 90. Let me graph sine theta real quick. If this is 0 and this will be 90, 180, 270, 360. I'll go to 450 while I'm at it. Sine starts middle and goes middle, high, middle, low, middle, high. Like that. Cosine starts high, middle, high, middle, low, middle, like this. So cosine starts like this. If I could take that whole graph and just shift it to the right 90 degrees, it matches. So you can take a cosine function and phase shift it to give you a sine function. Your graphs start at the point HK and should follow the scale. Okay, next is what I believe our last video for this chapter, graphing tangent. It's good. Oh, sheesh, that was a long one. I don't know what this guy was thinking talking so much, because it's a math video. No one wants to watch math for that long, but people do want to watch this sine wave go up and down and build what's, I guess, kind of looking like a Chinese finger trap here pretty soon. Am I allowed to call that a Chinese finger trap? Is that racist? I don't think it's racist, because that's what it's actually called. If you liked this video, please like it. That's a weird sentence. And if you want to subscribe to it, that'd be helpful. Thank you. Share it with a friend. And if you're taking this class, go take your video quiz. Don't forget about that. If you're a teacher who wants to buy the curriculum that's associated with this video, check the description down below. And as always, please feel free to leave me a comment and tell me how awful I am. There it goes.